Yeah, no, is it okay if Andreas records?
Yeah, perfect. Then I stop here.
Awesome.
Okay. Good.
Yeah, what else? Did anyone try like the joins and stuff? Should we do some more of that, or go through the next chapter of the book? I would do both, basically. Yeah. Network is low. Go. Okay. Lino 777. Are you here the first time? And Dermal VK. Test. don't. So if you hear us, you could like tell a little something about you.
I'm new here on Discord. I'm Ralf Vogelsang.
Okay, got it.
But I have to figure out everything, including camera and so on.
Yes.
So the chat is on the top right corner if you want to turn on the chat. And then if somebody's sharing the screen, you also have to click this. I'm always confused myself.
Thank you.
Yeah. So
and the account with the name of GRMLVK WK is probably on for hours. So I don't know.
Okay. So it's just
Maybe
like,
it's a mistake.
Yeah, that might be as well. Yeah, great. So let's I'm coming to the Discord now as well. Yes. You should hear and also see me, right? Yeah.
Loud and clear.
Okay. Yeah. So yeah. What are we up to today? We could do like the study course, the OpenUSD in a weekend, and continue it. I'll share my screen really quick. There we go. Green. Nelson. Let's show that guy. So now you can see it, right? And there we go. So where did we stop? I think the point features are now. We did physics, right? Or did you want to try anything more in with the physics joints and stuff? But I think we. Oh no, we did with this. Oh. But, That's maybe also nice, huh? Circle, 5 from ones. Oh, we did the robot thing, right? So yeah, so what do you guys think? No opinions? And so yeah. Ah, great. Yeah. So maybe point instancer or the joints. Good. Yeah, I guess. So we had point features. That's point clouds. Yeah. Okay, that's not point instancing. We did that like some chapters before. This is about point clouds, right? Okay. Yeah. So yeah, complex 3D scenes with millions of elements, particles. Yes. Points offer a solution by providing lightweight structural way to represent and manage dots but data sets. Yeah. They can streamline scene construction, optimize rendering, and make it easier to work with complex data. Basic point prims, convert point cloud data. Yeah, that's good. That's interesting, I'd say. Yeah, because if you do like start with a 3D scan, you either go by point cloud or now Gaussian splat, right? Which is also a basic point cloud. You could argue, yeah. Point instancer, yeah, okay, it's also about point instancer. Large number of instances using a single prim, making it ideal for applications, particle systems, vegetation. Yeah, I think we had a demo with a wood kind of scene, right? Of Ben. Curves. Yeah, sounds good. So points in 3D, yeah, X, Y, Z, right? We have the vertices. Individual points can contain rich data beyond simple X, Y, and Z coordinates. Yeah, we can find any information to like a point, right? Color, intensity, normals, classification, yeah, important. Time, custom attributes. Points aren't just vertical joints, versatile. USD geom points is basically the Python schema or the schema, USD schema. Find clouds, particles, point instancing, effect, simulation, yeah. Control points, rate. Yeah, point clouds, good. Now adding points to stage by creating popular points prim. Okay. Yeah. Let's see. That's chapter 9. So in case anybody needs to get the data, it's on GitHub. Let me paste that link. Chat. Oh yeah. That's also the link with Ben. The Omniverse Pioneers group is also very nice forum to get talks and news from the Omniverse ecosystem. Highly recommend it. So, okay. Then what we have. Chapter 9, we have like our assets, bunny zipper, okay, bunny. This is here. Remember to set the working directory, okay. Okay, create a new stage, define a points prim. Okay, so what do we want to use this time? Maybe code. And I'm using our USD root. There we go. Create a new terminal. And since we have a Python USD, and we have to activate our environment, right? Oh, it's already activated anyway, so it's good. Let's maybe do a notebook, right? So I do create new Jupyter notebook. Say print hello. You need to select the Python environment. Using maybe that. Yeah, it works. So no, we're using. I have the wrong folder actually. It's which one is it? Where did I put it? I'm on my laptop right now, so OpenUSD in that guy? No. Maybe I just downloaded it again. Sorry for that. So let's download this. Chapter 9. Learn USD. Oh, will be. Yeah, probably. Didn't we have that? There we have it. I just was not good to look. Code and assets, chapter 9. There we go. There's some code as well. Yeah, that's good. So let's put that here and open that one here, I'd say. Performer. Our directory as well. And there we go. Is it open? There we go. So, what's in assets? We have chapter 9. Do you see my screen, by the way?
No.
Oh, so I have to share that. Oh, it says I'm sharing. Strange. Okay, I share my screen again. Go ahead. You see it now? That's strange.
No.
Sorry for that. Can anybody else try to share their screen? If it's just my problem? Yeah, that works. Huh? Oh, do you see? Yes. Okay, so a little hiccup. Maybe I just share the window, right?
Can you hear me?
Yes, yes.
Yeah, in the beginning it was shared for me.
Oh, okay.
So now it's not anymore, but there was
Yeah.
an option, so I could see the images of everyone, and there was one of the squares that said shared session or something like that, but now it's gone.
Okay, let me retry. That guy, share.
Yeah, so watch stream it's called, and
if you
if I
click?
click watch stream, but now you are not streaming.
That's strange.
So when you asked, can you see my stream? I could see it, and then you changed something, and then it was gone.
Okay, that's so strange. Okay, let me try with maybe with a window then instead. Window once. What about that?
Yeah, that is working.
Oh, okay. Strange. Yeah. Well, yeah. Let's try it with that. And then let's see. Yeah, sorry for that. So okay, but that is. So I have to hop between windows then. So it says, yeah, maybe and use it like this. Change first the directory. Here it is. A new code, right? And we put in our directory, which is chapter. Did it say chapter 9, right? Yeah. Chapter 9. Copy path. And since we're using like the backslashes, I put an R here, right? Yes, trust. Oh, still need this guy. Install whatever. Okay. What does it thing? We read on. So now next experiment is to share the screen with the book again.
Jetzt ist der Stream wieder. Now the stream is closed again.
Hello. Let's try. Scheiße, ey, das gibt's doch nicht. Okay, now. Do you hear me again?
Yeah.
I don't hear you. This is, I mean, that's a little, that's not that good.
Can you hear me? 1, 2, 3, 1, 2, 3.
Oh, I see that. Yes, awesome.
Yeah, we can see your screen now.
Just for the You should actually also hear me, right? Do you hear me?
Yeah, we can hear you.
So I just don't hear you. Okay.
Test 1, 2, 3.
There we go. Now I hear you. Yes. Oh,
1, 2.
sorry. I just changed to the. I was on the web interface, and now I'm on the desktop client. I hope that works better. So now you should see my screen and as well everything else, right? So awesome. Oh, that's something. So yeah, so we've been here, we've created, we've changed the directory, and now let's go on. We create a new stage and define a points prim. So what happens here? We create a new stage, set the up axis, use this geom points define to add a prim, and set the default prim. Yeah, let's do that. Add some code. Sure, let's see if it works. So didn't have the USD library. So what do we have to do? We have to install it. Use the pip install and say USD core. I think it's USD core, right? Let's see. Yes. Okay. Install that. Now we have that. Just are you still with me? You see it, right? Awesome. So what did it do? We also do like the stage stage save, I'd say, right? Because now we just created like probably, if I look into this points example, it should be probably empty. Yeah, it's empty. Why is it empty? Because we didn't do a save, right? And I'm adding a new piece of code because now here we already had like created the stage, so the stage is still valid, right? In our notebook. So I just go here and say right, brink, yeah. Yeah, now if we look, we should have we expect to have a USD points prim. Right? Yes. See, here is the points. Okay. Populate position data for points. Yeah, looks good. So now we put like 3 positions into the points attribute and save it. Let's again add a code. So what did happen? What do we expect? We expect 3 values in the points attribute. Yes. Here we points attribute is an array of 0.3f, 1, 2, 3. Makes sense. Okay, so add width attribute to each point. So we have sizes. Okay. Yeah. That, or what does it at the same? Yeah, well, yeah. Go on. We do another code. Sizes. So yeah, and it suggests to save it as well. Yeah, that makes definitely sense. What do we expect? We expect a new width attribute with these 3 values. Pip. Let's see. Yes, new width, 3 values. Makes sense. Add the same color attribute to all points. Yeah. Yeah. So yeah. Now here we have just 1 value, right? And so yeah. Do it like that. It's another code. What do we expect? We have a prim bars display color with 1 value. Yes, here it is. Assign different colors to each point. So we have 3 values. We have have a primvars API, and we create a primvar with display color. Okay, and it says it's varying. Yes.
Didn't the most recent specs change the value type from vector to color 3F?
I don't know actually. If
So
you have a
maybe this example is outdated.
that might be the case, yes. But let's see what happens, right? So that accepts it. And you say it's like not a vec3f array, but like color or something, or
Not sure, but in the USDA file, they changed the type to stay compatible for the core 1.0 release to
yeah,
make it more
right?
compatible. Yeah.
Yeah, let's we'll see how it behaves, I'd say. Yeah. So we have our display color. Did we see the display color? Yes. Yeah. So we have a display color. 3 values.
Seems to work.
Okay. Good. So add dynamic color variations to points. So what do we have here? We have the C coordinates. So we get from all our positions these ones, right? The Z coordinates, that's 1, -1, and 0. We get the minimal value and the maximum value, that's -1 and 1, right? Yes. And we have an interpolate color, okay, which does some red and blue, okay, yeah. Dynamic colors, yeah. Yeah, let's see how it, did you already like, should we could also open the file, right? So we don't have just the UST, but yeah, let's see what it does. Yeah, so that was a uniform one. Yeah, just different ways of doing it. Okay. So save that. And how does that look like? Varying and some value of the T value, right? So yeah, it makes sense to look at it as well, I'd say, right? So I'd say I use Omniverse, right? Oh, Thomas, you already have opened it?
No.
Oh, okay. Let's see how that looks like. Oh, we also could like, is there? Did you post the link for the for this online UST viewer? US web view. Here, yeah. There we go. So maybe let's drop it in here, right? I had it. Where is it? Here. Oh, well, okay. That didn't do much.
So this
Drop it in
renderer
Omniverse.
What is it?
The web renderer is using 3GS, and I don't know if it renders points.
Like, yeah, okay, got it. Yeah. Well, let's see if even Omniverse does that as well, but I think so, yeah, right? Let's see. Zip. Did we have some points? Yeah, we have. Yeah, see, we have some points. Yeah, that's good. So that was our varying points. Now let's switch back to the uniform ones. So we have the comparison, right? No, last we did that. And now let's do, what does it do? Let's see. Let's do this one. How does it change? Fetch. Ah, yeah, so we have that like the red, blue, green. Why is that? Yeah, RGB, so red, green, and blue. Yeah. And now let's do the uniform. What would we expect? So with this, we would expect to have just every 3 points in green. Is that green? Oh, that's gray. Okay. Maybe it doesn't understand it right. Display color. Yeah, it doesn't make a difference, huh? Did like yes. Yeah, I doesn't like it. I'm not a lot familiar with these points renderings in Omniverse, so would be something to look up why it doesn't use this information. So when we put it here, yeah, it can deduct it, right? Yeah. I don't have an answer for that, but let's maybe just continue then. Converting point cloud datasets to USD. Okay, so we have the Open3D package. Or any remarks for you guys for these color things? Did you have experience with that? No, huh? So let's just move on. Points prim, or did we miss something here? Populating with the sequence like data structure. Yeah, we did that. Existence, yeah, we did that. Saving stage. Use hotkey F down, yeah. Load precision balance, yeah. Okay. Ah, yeah. Okay, so that was the effect of the width attribute for the points. Yeah, they're different size. Let's try different sizes as well again. I like that. Right. Let's do so. Wow. Yeah. Awesome. And it renders like the points as like a sphere, so that's really neat. Okay. Yeah. Appearance. So we did the display color. Yeah, so let's see what it says here. It's often used to apply simple color overrides. So like, it's probably useful and so on. Visualize an object with a solid color. Yeah, and that didn't work for us, right? Apply single line on points by default. It's only no special. Yeah. Plan form. Let's create a new. Yeah, that didn't work for us. So we had to like assign a color for each point, right? Functions, yeah. That's basically just what we did. We interpolated like the color or deducted the color from the position. So yeah. Yeah. So yeah, basically, yeah, the highest color, the highest point has the reddest color, and the lowest is blue. So we do that again. Yeah. That again, and do this again. Yeah, yeah. So yeah, as we see, highest point is red, lowest point is blue. In between is like, yeah, a mixture. Yeah, works as expected. Demonstrated that. Here's the points, prim. Yeah. So we can do some data visualization as well, like this, right? Yeah. Okay, point clouds, LiDAR, depth cameras, right? If you have an iPhone, you also have a Pro. You have a LiDAR sensor directly in your iPhone, so you can use that as well to do 3D scanning. Stored point clouds, yeah. Commonly stored formats are PLY here, XYZ, LAS, E53 is also on format. Install new package, okay. Yeah, let's do that. Install Open3D. Let's go. Here in the Jupyter Notebook, you have to add a % to install it in the same environment. And yeah, it probably takes a little time, so we read on. Notice come to see some error messages. Okay. It depends on common conflicts. So it's running to not affect the functionality for our purposes. Okay, so this should then work. Did we mention this one before? Spatial AI? No, I don't think so. Yeah, they did they posted a lot, right? Echo model. Jan, what is this? What do you just?
We don't, because I just wanted to post it. You don't have to go into this right now. It's just another Gaussian split thing and a startup from Munich, from TU München.
Nice.
So continue with your stuff.
Yeah, good. So it's still installing. So we have some. Oh no, it did something. Okay, porting connected. So as they suggested, we try to import this now. It does some things. Let's see. Yes, we have a version, so we installed that. Awesome. So what next? This prints a version number. Yes, we have that, and we have especially the same version, so that's good. Now we're ready being screened down the way by setting a working directory and importing the modules. Remember to set your working directory to chapter 8. Did we set it? No, we set it to chapter 9, so we set this to chapter 8. Yeah. Okay. Chapter 8 is here. We have the assets. What is, I think, yeah, that's a typo. They mean chapter 9 because here we have the bunny zipper res, right? So let's go back to chapter 9, let's say. Okay. Bun zipper res 2, yeah, that's this one. We're going to walk you through the process converting zipper into a USDA file. Okay. We'll begin the process by importing the modules we'll need and loading point cloud data from PLY file. Relevant data, we can run the stage and define primitive. Okay, yeah. That also correlates to like this USD data pipeline chapters in the USD learning path. I'll link it. Yeah, so let's load then the assets bun zipper like that. Presets colors. Okay. Yeah, let's do that. Let's try to load this. Let's create a new code. Well, yeah, whatever. So this should now load this. We are in this chapter 9 directory, and it should load the bun zipper res and the points. You know, let's maybe print out some points len, so it should print something other than 0, right? See, yeah, it loaded the point cloud. It has loaded 8,171 points. That's cool. Can we look into the PLY file? Yeah, see, this is the PLY file, and these are the points basically. Yeah, the vertex indices are probably then here. Yep, okay. I think Omniverse should also be able to read the PLY file, right? So we can look at it. I'm not sure myself. No, probably not. Oh yeah, it can convert it. Yeah. Yes, that looks like it. Maybe you should use it as a separate. So let's do the camera lines. Don't we have like the? Is it? Where is it? There it is. Yeah, nice bunny. Well, the near and far plane is a little too. So see, as I go to the more to the it gets clipped, right? And you can somewhere you can like adjust the near and far plane. Where is it? Here we have the clipping plane. See, here is the far plane, and here it's the near plane. So if I go to like one, like this, right? So we can go just in the near of it. So in case you're asking yourself why is it clipped, here it's a setting of the camera. Yeah. So that worked. You can extract color information from a PLY data if it exists and create a list of GFVAC values from it. Also, the file we're converting doesn't contain color data. Yeah, we see it's just gray. We'll include this step in the process. Okay, and the cases where color data is missing, there's something else to apply default white color to the points. Yeah, let's do that. I'll do that just here as well, right? So next we create a USD stage to define prims. Point cloud conversion. Okay, makes sense. Conversion. The scaled point cloud. Okay, and our points as well. Yeah, so far so good. With the points prim created, let's use the points and color listed from the earlier to set the point positions and colors. Adjust the point width and apply 100 scaling factor to the parent transform. Okay. So we set the points to our points prim as we did before. Set the points. Also, we set like the colors. We did that, right? And we set the width by this. Yeah. Applying scaling, and we scale it. Yeah, all straightforward, right? So put that here. Anything else? No. So let's give it a go. Yay, you took the point cloud conversion. And what do we expect? We have a scaled point cloud root node, a bunny below with points, and a lot of points and a lot of display colors, right? Let's see. Yes. So points, display colors, everything set to white, right? And width is also set to each point. We have a white and the width that's set to 0.005. Yeah, makes sense. So now let's view the stage. Select the bunny prim in there. Yeah. Yeah, let's see how things work out now. So what did we do? We had that here in chapter 9, right? We had that here. Point cloud conversion. Indeed, we have a nice snow kind of bunny. Yeah, awesome. So the station, yeah, we saw that. Adjust the width value. Yeah, let's do that. It's good. So we already have like this, right? So we just add our little code here. So we set the width from what did you have before? Is here? So we do it bigger. Okay, yeah, let's see what happens. So it's probably like now really, it's strange. Yeah, let's see. Oh yeah, see? It has bigger points now. Let's maybe set it really to something really small for comparison, like that. Oh. Too small? Probably, huh? Yeah, that was too small. But yeah, here we see it like the little points. Also nice. Consider high resolution model. Yeah, normally a point cloud of a scan has like billions of points. But still, yeah, that's cool. So next would be utilizing the point instancer, but I think we're running a little out of time. And I have another meeting after this. So I think, yeah, we call it a.
I've got a note.
Yes.
So if you look for PLY files, very often you find very fresh created ones, and they will have another file format.
Oh.
Probably not as a point cloud, but PLY files can also store Gaussian splats.
Yes. That's
and some software cannot cope with it.
Yeah, that's kind of a very used format for Gaussian splats as well.
Yeah, the spatial that I posted in here, they also provide PLY files.
Yeah, maybe let's download one. Do we have still a little time? I don't see any.
I think you have to log in.
Yeah, well, no, that's but yeah, we'll try. And these guys are from Munich.
Yeah.
Nice.
Okay, I've got, maybe that works. No, it's too big. Okay, 1 second. I'll give you a download link in a second, okay? I tried something earlier there.
Splat, do you know Splat Gallery? Okay. Interesting. Use public data, that sounds good. Oh, yeah, okay. 3 million splat, well, yeah, that's. Did you mean this? No? Let's download and look into it. By the way, if you want to look, well, we did that, right? The Gaussian splat in Omniverse. There we go.
In the Google Drive, there is also the Plies PLY files.
Oh, nice. How large is it?
They're big.
Oh, yeah, that's also big. Yeah. That's the Gaussian splat or that one, or both?
Both, I think. I haven't really.
So download that. And did it already download? The cluster flight already downloaded. Now extract that. The compressed, I think it also downloaded already. Yeah, that's good. So, so yeah, can we look into that as well? No? Yeah, probably too low. Oh yeah, so yeah, okay. So the header is also like like normal and then it has different. So, but here you also see it's like these are the informations or the values in the. Oh yeah, I have to leave in a minute. For each point, right? So no, that's good. Let's quickly try to load that as well. It's in downloads. 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 Yeah. That. I just try to load it. And it's okay now this, yeah, this is exactly what happens if you haven't activated the Gaussian splat extension. I'm looking for the Gaussian splat extension now. See, yeah, install this.
You got 10 more seconds.
Yeah. Sorry. Yeah, I think we have to do it next time because this is also not the. Oh yeah, it should. Yeah, it's probably one version too old. But yeah, we'll do that next time then. Let's say.
I'll also test it.
Great. Yeah.
Yeah.
Thank you very much.
Sorry for the hiccup in the beginning. Next time I think we're good again. And yeah, have a great weekend. And talk to you next week.
Thank you.
Goodbye.
You too.
Bye.
Okay.
Cheers.
Bye.